Hi guys, sorry I'm not able to be with you there today, but I did want to record some of the things that I wanted you to get out of today's lesson. So hopefully at this point you guys have completed the note check section of the lesson, and I wanted to go over a couple of things with you guys that you should have discussed with each other after watching last night's homework and completing the note check from today. So, first things first, let's talk about the fact that this is the first time that we're going to talk about a reference sheet for AP Stats class. In terms of the scatter plot unit and dealing with linear regression, which is the comparison of two quantitative variables. This is the first time I'm going to talk about formulas that are being provided for you on the reference sheet. These are the specific formulas that are provided for you on the reference sheet. And while that may seem like a positive, let me explain to you why I actually don't think it's anything that exciting. When you take a look at the first equation here, you can actually see that this is really just the equation of a line, right? Really, this is just y equals mx plus b. The only difference is your y gets a y hat to communicate the fact that these are predicted y values from your linear regression. And they just call the y-intercept b sub 0, and they call the slope b sub 1. As you're going through some of the other formulas, like this one down here, this formula down here is actually exactly the same as the one above. It just communicates one additional piece of information that says that if you have the linear regression model, or if you have the line of best fit or the least squares regression line, that line will pass through the average of the x's and the average of the y's. Really, if I were to take y hat equals to b sub 0 plus b sub 1x and just replace that with y bar, b sub 0 plus b sub 1 x bar. And if I were to just solve for b sub 0, y bar minus b sub 1x is b sub, that is this formula. So these two formulas are exactly the same thing, just with this added concept that the line does pass through the average of the x's and the average of the y's. This particular formula here, in terms of solving for the slope, I've never really seen that one used. Been teaching it for like at least 17 years, and I really haven't seen that formula used in terms of solving for the slope. However, when you do have to calculate the least squares regression line by hand, if they only give you statistics, if they don't give you the data itself, I have seen this formula needed to be used to solve for your slope. But if they do give you the average of the x's, the average of the y's, and the standard deviations, note if you use the bottom formula here to solve for your slope, you can go back and find your y-intercept after by using the average of the x's and the average of the y's with the slope together. So, as I'm really saying to you guys, yes, this is the first quiz and test you will start to get a reference sheet for. This is the very big, important new equation that you would need to know. Just a reminder that this one here is also the same thing as the equation above, just the fact that it discusses that it passes through the average of the x's and the average of the y's. And this formula will help you find your slope if you're not given the data itself, but just given the summary statistics. Okay, so now that we talked about what is going to be provided for you, let's talk about a couple of other things. Talking just about association in general, please note that association does not mean causation. It just means, is there a relationship between the two variables? So you can take a look and check your positive, negative, or no association there. I'm going to move on to example 2 though, because that's where we start to hit the really important stuff. So for number 2, you guys should have made a scatter plot for your data set. Notice the two axes for your quantitative variables here. When you design the scatter plot in this way, okay, there's a couple of things I want to mention to you. One, notice here my scatter plot has a break because I'm not starting at 0. I'm jumping from 0 to 60, then going 60 to 70, and 70 to 80. Same thing, I jump from 0 to 100, so there's a break on my y-axis. Please be careful that if you do decide to skip from 0 to the number to change the scales to better see it, just include a little break on your axis so we can make sure that we're taking a look here. Also, I'm going to assume that you also made the executive decision that your height was going to be your independent variable and your weight was going to be your dependent variable, which is perfectly fine. But do note that when you make that decision, it means that you're using the height to predict the weight. Okay, so everything has to be in the order. Use the height to predict the weight. All right, if you want to do it in the opposite direction, that's fine, but you'd have to create a different scatter plot where the weight was on your x-axis and the height was on your y-axis, and you would have to complete or recomplete all of the calculations of the least squares regression line. You'd have to find a different slope. You'd have to find a different y-intercept. Okay, so if you want to make a prediction from weight to height, you'd have to reverse everything. But for the most part, for this scenario, it makes sense to use your height to predict your weight. Now, for this next question, it says, describe the relationship between the height and the weight. So when they're asking you for the description of the relationship, note that they're going to ask you for form, direction, and strength. Okay, form, direction, and strength. So strength could be strong, moderate, weak. Form could be linear, curved. Okay, direction, positive or negative. So for this particular one, I would say that it's a strong, positive, slightly curved association, because you can kind of see that it dips down here and kind of curves back up a little bit. If you said that it was moderately linear, if you said linear, that's okay, but they really want you to indicate the notice here of that slight curve that's occurring in the data set as it curves up from the bit there. Then part C asks you to calculate R and interpret R in context. Remember that R is your correlation coefficient, okay? Correlation coefficient will give you direction and it will give you strength. By default, the correlation coefficient only describes the strength and the direction of a linear relationship. So the form is implied from the fact that you're calculating R, because R is only associated with linear relationships. So notice the R value here is 0.91585. That would mean that there is a strong linear relationship. It's going to be positive because that number is positive in general. Remember, your correlation coefficient can only go from -1 to +1. Anything negative, meaning that there's a negative linear relationship. Anything positive, meaning that it is a positive linear relationship. If R is equal to 1, that means it's a perfect straight line. And if R is equal to -1, that means it is a perfect straight line, just in a negative direction. Just a reminder, if you are not seeing the R in your linear regression calculations, that you're just going to go to mode, and you can actually turn on your stat diagnostic to make sure it's not off, make sure it's on. And if you have it as on, then you can get your correlation coefficient right from the calculator. You don't really have to do any calculations yourself from that. So again, stat calc, lin reg. We have our L1, L2. I already have the data in there from before, and it will produce it for you. I know here that there is an R squared. We'll talk about that in the next lesson. Okay, for part D, it does say write the equation of the least squares regression line. So here, notice everything is coming right off of the calculator. If they give you the list of data itself, you just put it into our L1 and our L2, and it will calculate the least squares regression line for you. There are a couple of things here, however, that I do want to talk about how to write it, because if you only wrote this as your answer, if that's the only thing you wrote, you're not going to get full credit, okay? So if you write it like that, you must define each of your variables. You have to define the X as the height, and you also have to define Y hat as the predicted weight. It is critical that you have the word predicted, okay? That is not the actual Y value. It's not the numbers that are coming from here. It is the predicted weight, right? If you write a least squares regression line through your data set, or if you draw a least squares right through your data set, is talking about these predicted values of what you anticipate given each value for X or each value for the height. These are not actual weights, okay? Another way to write your equation, so they're kind of tackling two birds with one stone, you could also write the words under the symbols, like predicted weight equals your number. You write the word height and then your y-intercept at the end, okay? So there's two different ways, but either way you have to define your variables. If the variables are not defined, you will not get credit for writing the equation on the regression line, okay? For number 3, again, notice here it says, does there seem to be an association? So yeah, it definitely does seem to be association, but notice there's a bit of scatter as you go up. So when I'm looking here, there are two things I want to mention. Okay, there is a moderate positive linear relationship between height and weight. So I see form, direction, strength. And then once you see this word here, this is where you start including your context seen between height and weight. Don't forget though, just like regular data sets, there could also be outliers. This point here does seem to be an outlier. So there seems to be one outlier, and I record the point there for purposes of describing where the outlier is, okay? So big thing here, form, direction, strength when they ask you for association, and don't forget your context. So notice just by adding between height and weight, that does fine for the context, and then I include a description of an outlier. Last but not least, on the last page, guys, notice the difference between question number 2 and question number 4. Question number 2 gave you the data set directly. Question number 4 didn't give you the data. Yeah, they gave you a scatter plot, but you can't figure out where those points are. So if they give you a mean and a standard deviation and the correlation coefficient, that's when you're going to have to use the formula to find your slope using the standard deviations. So notice here, I solve for b sub 1 first. This formula is on the reference sheet, and you get your slope of 0.18907. Okay, once you have the slope, you can then go to your linear regression line and recall the fact that your line must pass through the average of the x's and the average of the y's. If you use that and your slope itself, you can solve for your y-intercept, which is 0.109177. So notice when I wrap this up and I write my final answer, here is not only the equation of the linear regression line or the least squares regression line or your line of best fit, but notice I have also defined the variables below and my y hat as my predicted gas mileage usage. Okay, now here is also at the next step is to talk about interpretations of slopes and y-intercepts. Now this here, what we're going to talk about, this is going to be the same for every single question. It's kind of like formulaic when you write these interpretations, right? If I said to you out of the context of AP statistics, what is a slope? You tell me is how much the y increases for each increase in x, right? So we're just going to take that vocabulary and we're going to transition it over, okay, to statistics. And notice here, anything in black, guys, that's the part that's going to stay consistent from question to question to question. It says for each increase in, and then we define our x variable, which in this case says degree days, right? It doesn't even matter that I don't even know what a degree day is. All that matters is the fact that for each increase in x, the predicted, notice the word predicted, you must mention the fact that this is an equation for predicted y values. So it says the predicted gas usage will, and now you can fill in increase or decrease depending on the sign of your slope by, and you fill in the value for your slope. Okay, so slope is how much the y will increase or the predicted y will increase based on each additional increase in your x variable. Same thing with y-intercepts, right? If you go back to the pre-calc days, a y-intercept, right, is your y value when your x is 0. So here at 0 degree days, right, or at 0 and then my x variable, the predicted, again, predicted y value, gas usage, is, and then I fill in the value with a little bit of context and measurement. It's really important, guys, to note that when you are doing your least squares regression line that goes through your data set, right, it's going to fit the data, show the trend, something like this. Now, the whole point of writing the least squares regression line is to be able to make predictions. Look at when you look at degree day 40. Okay, when I look at degree day 40, so I'm going to go here, there's no actual true point at degree day 40. There is no actual data point on the graph. So what this allows us to do is says, well, if I know that this is the trend of the data, this least squares regression line, let me use that equation to find the predicted value of what I think would come out. What would be the gas usage if the degree day was 40? So notice we take our least squares regression line, and the only thing is we substitute in that value for x, okay, into the equation, and then you calculate your predicted y value. So in this case, if you have 1.0177, I'm just going to get an actual value for you. Hold on one second. There we go. We have 1.09177 plus 0.18907 times 40. This turns out to be 8.65457. Remember, 7 decimals is the standard. 4 decimals is the standard. And that makes sense because when I go up to the least squares regression line, 8.6, that would be about here. Oh, I went a little too high. It would be about here, okay? Maybe not the best. The way that I drew it maybe doesn't line up perfectly, but you can see that it does match the linear regression model from what we predicted. And the same thing when you're predicting for 20. So you guys are responsible for this material. Everything that I discussed in terms of the small things in this lesson is exactly what I've given to the other classes. So you do have additional videos for tonight for the next class. I will take any questions you guys have on this lesson the next time I see you. And then we will probably have a quiz the next time after that. So please make sure you feel good about this material. There's wonderful practice problems below, ones where I give you the equation already, ones where you have to write the equation yourself from means and standard deviation, so from statistics rather than from the data. There are questions here with data being provided where you have to use your calculator, and some great interpretation questions about how do the correlation coefficients connect to the scatter plot. So the practice here is actually really great for you to study and make sure you understand everything, but everything else is here. If you have any questions, guys, about the material from today, please feel free to reach out. I will be back in tomorrow. Thank you for understanding about my absence. Have a great day.